So for this one, I would use substitution. So u is 2x plus 3. D is 2 times dx. And dx is equals 1 over 2. So this would be plus 2 is outside. And this would be 1 over u. 1. And you can change the limit also. If x is equals to 1, u will be 5. Or negative. So if x is 1, x is 3, so that's u is 9. In the beginning, I think it will work if it's -1. So when you get to that point, so change that to -1. So it is -1, my mistake. So that's the only thing the limit is -1. So that's if this is e, this would be s. Yeah. So that's limit goes from -1 to 3. When you get to that point, use it. So ensure you're working on that part. So this 2 will cancel this 2. So that's going to be plus. And we solve that.
Professor?
Yeah.
Can I see the answer to number 2 one more time? I just want to confirm one thing.
Yes.
Okay. Thank you.
You're welcome. Were you able to get the answer? -4 plus 2 natural log of 3. So that's the continuation of that. Yes, if you carefully use all these formula we have on these pages, it should work, but it's not that difficult or impossible to solve. So any question on these two in classwork or any part of it? All right, so that's the solution step by step I solved. So we're gonna move on to the last section for today, that's 6.6.
Professor, I had a question.
Yeah.
So the one that you just did for number 2, would it be fine if you leave it as just natural log of 9?
Like I said again, the computer may accept it or may not, but 9 is a perfect square. It's okay if it was, that's also a good answer, but sometimes if it's a perfect square, they want you to reduce it. I would say 99.9% is good, but just that 0.1%, if it's not accepted, then use that. Yeah, anytime the power, because 9 also has a power. It's a perfect square. If it was 7, it would be okay. If it was 8 is 2 to the third, not good. Like if it was 5, it's okay. As long as it's not a perfect square, that's okay. But if something perfect square, like x squared, x to the fourth, x cubed, then move those, anything with the power. So I cannot make 5 as a raised to some power. I can make 9, 16, 25. Those are all perfect square. Yeah, so. All right, so section 6.6 is called the moment. Moments and centers of mass. All right, so there are some formulas. So our ultimate goal is to find the center of mass. So if they give you a metal or a board, and if they ask you, where is the center of this? They have to give us the thickness of that. So if we have the density of this, so is the center is here exactly, or the center is here. So let's say the center is here. But what if they give us something, they put a weight on each end. So let's say they put 3 kilograms on this side, and they put 2 kilograms on this side. So now is the center more in here in x equals 0 or in this side? So then they have to have a distance on this side. They have to have a distance on this side. So the moment is distance times mass, but we're just finding the center. So if they give you something in center, we have to know the distance in something like this. But now if they give us a density and thickness, so we can use the integration using some formula. So they want to know center of a mass. And weight, if I move this to this side, is gonna, this is 4 coulomb. So is it gonna go, this is not really gonna find, but I'm just giving a general example. What would be the center is if it's not even balanced. So there's the formula we have. This would be the origin. So mass formula is given. So that's N, that's they're asking us to find from A to B. That's delta X, that's the thickness or density or the function, that's dx. The other formula we need to know is moment. So moment about the origin, because we want to know where is exactly at the middle. So that we call origin will be labeled as a M sub O. So this would be M sub O is equals A to B times X, and this would be the thickness or density of dx. So that's one formula. This is another formula. Then out of these two will allow us to use the center. Center of a mass or weight will be just the X bar equals to mass of origin divided by mass. So we use this formula. There's a lot into this, but a lot of it must be done by a program or graphing calculator or something. But a lot of time we don't cover this section, but I'm just going to cover very basics of that. So if you look at the homework, I think there's only 2-3 problems are assigned out of this section, and I'm going to do the same. So I'll give you 2 examples that will take care of everything you need to know from this section. Other than that, we have to have a perfect picture drawing, and so they're not asking us. So I'm just going to do problems out of your book. So any of these 1 to 4 will cover these. So I'll do one of the example. So I'll give you 2 examples. In general, we don't cover this section, but I'm just going to base touch on this. So it'll be simple. So our goal is to find the center of mass as long as they give us the density or thickness. And like for example, I'll do problem number 1, section 6.6. This is on page 363. So you'll see similar questions on in the homework as well. And so let's say they give us the density or the thickness of the metal, whatever that sheet is. So that's the square root of x. And now the limit of integration is also given. So 1 to 4. And so for in this purpose, we will just use that formula. So first we need to find the mass. And that's the capital M by itself. And that will go from A to B of density times dx. So mass will be 1 to 4. And the density function was the square root of x that's given, and times dx. So very simple, we're going to do the integration of that. So that this is the same as 1 to 4 x to the 1/2 times dx. So m will be you raise this to the ones, so that gives you 3 over 2 multiplied by 2/3, and that goes from 1 to 4. So this would be 2/3, and you put upper limit 4, 3 over 2. This is minus the lower limit, so also 2/3 of 1. And we have to calculate this. So when you simplify it, so that gives you 14 over 3. So this is our mass. Now just remember, this gives you 1 times 2/3, and this is the same as 2 to the 3rd power, so that gives you 8, and at the end you will have this. So simplify that. Okay, so then after we find that, we need to find moment at the origin, so that will be m1. So the value of this would be A to B, x times the density times dx. So just be careful, that's the only new thing is this will be multiplying by x. So this will be moment at the origin, so that goes from 1 to 4. So we have x here, and this is the square root of x, and this is times dx. So now you may want to combine these two. So this will be integration goes from 1 to 4. This is x. This is x to the 1/2. So this will be times dx. So the moment of this integration goes 1 to 4. So this gives you 3/2. So in power of this is 1. If the base are the same, we add. In multiplication, we add the power. So now we can have this integration of this. So we're going to add 1 to this power. So that gives you x to the 5 over 2 divided by 2/5. And that goes from 1 to 4. and the rest is all you can use a calculator. So that would be 2/5. X is the upper one is 4. So that's 5/2 minus 2/5 of lower limit is 1. So that's 5/2. So if you solve this, so that gives you 62/5. So this is, and so if you're allowed to use a calculator, you can simplify. So now our final answer is all about the center of that mass. So we have to find the moment. We have to find the moment at the origin. Then this allows us to find, and now, so the X bar is very simple. So that's going to be moment at the origin, and this is mass. So this was, actually this was a 62. Yeah, so 62 over 5 divided by 14/3. And just use the 62/5 and do the reciprocal of that 3/14. Let's see, where is that equals to? You can leave it as a fraction, so 62 times 3. So that's 186. And that 14, so that gives you 70. So that's 93/30. So that's the X bar, center of mass. So very simple substitution. We're not, like I say, we have to have some kind of program to draw this for us and find all of the information. But we just doing the part that find the center. And that's very simple integration. So it's not very complicated. I'll give you one more example. In the homework, you have 2 or 3 problems, very, very similar to that. So then the rest, if you have any question, you can do that. So this part, I may have done shortcut, but you can do expand it so it's not that difficult. So one last problem I'm going to do, and that will take care of this, everything you need to know for the homework out of this section. So use this page. Okay, so one more problem. So this time I will do the same, another exercise. So let's say the density function is giving 8/x cubed. And x is between 1 and 2. So density function also, this is the same as 8x to the -3. So it will help us to do with the integration on this case. So we need to find the mass first. So the mass will be integration from A to B times density times dx. So this is 1 to 2. And the density function is 8x to the -3 times dx. We'll take the integration of that. So this 8 is a constant. So we're going to add 1 to this. So this becomes x to the -2 divided by -2. And it would go from 1 to 2. So this will be the same as -4 x to the -2. That's the same as -4 x squared, and you can apply 1 to 2 in here. So this will be -4, and this will be 2 to the second, which is 4 also, minus -4 and 1 squared. So that gives you -1, and this gives you negative of -4. So that gives you +3. So that's a +3. Okay, we need to find moment at the origin. So that formula is A to B, integration of A to B, x times density, that's the thickness. And so this will be 1 to 2, x times, and the function was 8x to the -3 times dx. We want to combine these two. So the moment at the origin is integration goes from 1 to 2. So this would be 8. This is 1. If you combine these, so that gives you negative 2. So x to the negative 2 times dx. So when we do the integration of that, 8 is a constant. You add 1 to this, so that becomes x to the negative 1 divided by 1. So it'll be 1 to 2. You can rewrite this as an 8. Pull the negative outside, so that just gives you over x and 1 to 2. So that's the exact same thing. And that's the same as negative 8, 1 over 2. And this is negative 8 times negative of this will be 1 to 2. So that's like that. So which is the same. So this gives you negative 4. And this 2 negative gives you positive. So that's 8. So the answer is 4. So now the last thing we want to find the center is very simple. So the formula is given x bar equals moment over mass, origin moment. So we have this is 4, this is 3, and just leave it as a non-decimal. So, and these are the 2 type of questions you're going to see in the homework, nothing beyond that. So find the mass, find the moment at the origin, and find the center. But the density of all those things, you need to know the distance, like I give you. If they have a weight on one side, wave on the other side, you need to know exactly the distance and to order find exactly. But this is all calculated for us. We just have to apply the formula. And much easier. And that's all I have for today. And tomorrow we'll finish the last section, 8.2. And those are everything we do is new. And I send you the practice test. You should be good to working all the way to the last 2-3 problems of practice test. And the rest is all we cover. So in your lecture notes and Canvas is available. Okay. If you're done, you're good to go. If you have any questions today, I can help you with.